Welcome to Cosmic Lab, bro. Today, we're going back 252 million years to the single worst moment in Earth's history. Not an asteroid like the dinosaurs. Not a slow change. This was fast, brutal, and almost ended complex life forever. Scientists call it the Permian-Triassic extinction, or simply the Great Dying. In less than 60,000 years, a blink in geological time, more than 96% of marine species and 70% of land species disappeared. Entire ecosystems collapsed. Coral reefs vanished. Forests turned to wastelands. The planet took millions of years to recover. But why did it happen? And what does this nightmare teach us about our world right now? Let's dive in. It all started deep in what is now Siberia. Massive volcanic eruptions, the Siberian Traps poured out over 4 million cubic kilometers of lava. That's enough to cover the entire United States in basalt, half a kilometer thick. These weren't normal volcanoes. They were flood basalts, continent-sized lava floods that lasted hundreds of thousands of years. The eruptions released enormous amounts of carbon dioxide, methane, and sulfur gases. CO2 levels skyrocketed, triggering runaway global warming. Temperatures rose 8–10 degrees Celsius on average, some places much hotter. Oceans turned acidic. Oxygen levels plummeted. But the real killer was in the water. Warmer oceans hold less dissolved oxygen. Combined with massive nutrient runoff from dying land plants and volcanic ash, huge algal blooms exploded, then died and decayed, sucking even more oxygen out. This created vast dead zones across the global ocean, anoxic events on a planetary scale. Marine animals suffocated. Fish, trilobites, ammonites, reef builders gone. On land, hyperwarmed air caused acid rain, wildfires, and toxic gas clouds. The food chain collapsed from the bottom up. Survivors were rare. Small, tough creatures like Lystrosaurus, a pig-sized reptile that became the most common land animal for millions of years afterward. Recent research using uranium isotopes, mercury spikes in rocks, and carbon cycle models has pinned the timeline tighter. The main pulse of extinction happened in just tens of thousands of years, triggered by repeated volcanic bursts. Some studies even suggest methane clathrates, frozen gas deposits on the sea floor, released suddenly, supercharging the warming like a planetary pressure cooker. The atmosphere turned into a greenhouse nightmare, CO2 levels possibly 10–20 times higher than pre-industrial Earth. Recovery took forever. It took 5–10 million years for biodiversity to climb back. New groups rose: dinosaurs, early mammals, modern-style reefs. But the scars remain. The Great Dying set the stage for the Triassic world we see in fossils today. So why does this ancient horror matter now? Because we're running a similar experiment: fast-rising CO2, warming oceans, deoxygenation, acid rain from pollution. We're not at Permian levels yet, but the trends are eerily familiar. Dead zones in our oceans are growing. Coral reefs are bleaching at record rates. Species are disappearing 101,000 times faster than background rates. The Great Dying shows Earth can be pushed to the edge and come back, but recovery takes millions of years, not decades. It reminds us life is resilient, but ecosystems are fragile when change happens too fast. We are not doomed to repeat history. We have knowledge the Permian creatures never had: satellites, models, renewable energy, conservation. Every choice today shapes whether we trigger our own mini-extinction or steer toward stability. The Great Dying wasn't the end of life, but it was a brutal warning from deep time. Earth has survived worse. The question is, will we? If this hit you hard, smash that like button to spread the message. Comment below, do you think modern climate change could cause a mass extinction like the Great Dying? Or what gives you hope? Subscribe to Cosmic Lab and turn on notifications. We keep uncovering Earth's past, present, and future every week. Thanks for watching, bro. Stay curious and take care of our planet.